Okay, Abdul. Okay, so we till date we have covered the application layer,
Yeah,
right? And
yeah, yeah.
we have remaining 6 more layers to cover. So let us start with a presentation layer, and just for you know like just for our understanding, just let us check what are the 7 layers. Physical layer, and then we have something called data link, and then we have network, and then we have transport and session, presentation, application, right? Okay. So, and we have seen what is this application layer is and what it does, and there were two different classification like network application and non-network application. And in presentation, actually, what does it means? Like, okay, just think of like this is your laptop, and you have opened a browser, and let's say that in that browser you have different tabs open. Let's say that one is for YouTube and one is for Facebook and one is for some ABC. Okay, so whenever you go to YouTube, so have you identified like that there is a change in the web page, like your profile about your the thing, always it will be there, and your playlist will be showing here, and also like some more menu will be here. Okay, have you seen any time like on one tab you are getting this view, on the another tab is there any change in view, something like that? Have you experienced? No, right? John, are you talking? I can't hear you.
You can hear me?
No, no, your mic is too low.
It's too low.
Yeah, yeah.
Oh, okay. Let me put it up. Is it okay now?
Yeah, yeah, it is better now.
Okay.
Okay, so why it is always these views are constant? So it is, we are not taking a printout or Xerox or whatever it is. We are requesting something over the internet, and we are getting the reply from that web server somewhere in the internet. But whenever I open that web page, it is always in that same constant format until unless the that particular company developer change that view. So why how it is happening? Because how we are actually receiving data, let's say that I'm having one laptop and you are having one laptop, and we are connected through some sort of cables, and we'll cover this what cables are in later chapters. And let's say that you wanted a movie Avenger from me. I have that in my local locally present in my computer. Okay, now I started transferring uh, over this wire to your laptop or desktop. Okay. So meantime, if we peel off this wire, can we see the data? Like, can we see the movie, Avenger movie, the scenes what I actually am sending to you?
Hello?
Yeah, John. Hello. Am I
Yes.
audible to you?
Yeah. So if you're sending it to me
Yeah.
and you said if the cable is not connected.
Uh, the cable is connected. Okay.
Mhm.
I'm sending the data. Meantime, if I peel off this cable just to see what it is happening inside, whether
Mhm.
is there any chance that I can see this Avenger movie scenes over that cable, that actually inside the cable?
Of course not.
Exactly, right? So so in what means then we are transferring our
that is gonna be like magic then.
okay, so that magic we are not doing it here. Okay, so so in what terms, in what means the data is being transferred from node A to node B? It is in
Hmm.
binary format, okay, like in terms
Yes.
of 0 1 0 1.
0 1s. Yeah.
Yes, once it is being received to your at the receiver
Laptop.
end, at the
Hmm.
destination end,
Hmm.
then it will process on the data and it will give you a nice picture, movie, whatever, however it is.
Yes. Yes.
So it is the job of the presentation layer. Once it got any data, okay. So how I need to represent this data to the user, end user, over the application. So this is the job of the presentation layer. Let's say
Right.
that for one more example, like again coming back to this YouTube, okay, all these fields are being set, okay. If it is
Hmm.
the length, if it is the width of that particular size of that laptop, what the user is using, or tablet or whatever it is, okay, this icon should go here. If it
Hmm.
is tablet, then this icon should go here, something
Hmm.
like that. They have
Hmm.
their dimension has been already defined. So whenever you are receiving the data, this presentation layer know how I need to represent this data to the user and at which pixels and where I need to represent in the
Okay.
screen.
Okay. So the job of presentation is to always present it the way it's sent to the end user. Yes.
Exactly. Yeah.
All right.
Also, one good example that I can give is like we are typing in keyboard like A B C D whatever it is with caps lock on with smaller
Hmm.
keys.
Hmm.
But how does we are okay? How the CPU is understanding that whether it is A or B? We are just typing the keyboard, right? So in the
Hmm.
background, what happened is like for each keystroke, there is something a frequency it will get generate. Okay, so if
Okay.
that frequencies get generate, then CPU understand that okay, it is a cap uppercase A. If this
Oh.
frequency, then it is a lowercase a. So how this is being done is using something called ASCII format.
SP.
ASCII,
Okay.
okay, American Standard Code of Information.
Okay. But that's the same thing we see in the same thing I've seen in what do you call it? The router security, like a WAPA, WEP, and then ASC,
Yeah.
ASC, ASE1, ASE2 as the authentication, like security. Is it the same?
Uh, uh, no, I
You know,
didn't get you.
like when you are connecting your Wi-Fi, you can
Mhm.
choose between WAP, WAP2, or ASK. Yeah,
Okay. Yeah.
is it the same?
Uh, it is not same
Similar.
because
Okay.
no, they are not similar actually. Their functionality wise, if you see that like this AES, DES, they do different sort of mechanism.
Things.
Okay,
Okay.
they
Right.
don't represent the data. Actually, they do something called encryption, decryption, something kind of that thing.
Right. Right.
Okay, here the ASCII what I am talking is it is what we call as American Standard Code for Information Interchange. So
Interchange.
based
Okay.
on that, our keystroke in our keyboards actually it works. It is some protocol that I was referring as an example for the presentation layer here.
Right. Right. Okay.
So basically, this is the job of the presentation layer.
Okay.
And if we come to a session layer,
Mhm.
okay. So in this session layer, actually, it is very much interesting. Why? Because since now how we have studied about something called different protocols, right? In each application, but in session layer, there is something called a port numbers. It is not a protocol. It is something called a port numbers. What we'll call. So what is the use of port numbers? That means again, coming back to the same example, it is your laptop and you open your web browser, and you have opened multiple tabs. One is for YouTube, one is for your banking, and one is for some Netflix, whatever it is. So have you ever experienced, okay, you have requested banking here and you have using Netflix here. So have you ever seen the Netflix data on the YouTube tab, and YouTube data on the banking tab, and banking data on the Netflix tab?
Mm.
No, no, right?
Oh, no, no.
Okay. So being a human, we know that we have opened different tabs for different sections, but how CPU understands it, it is receiving all the data at a time. So through internet, in
Yes,
some difference in some milliseconds or microseconds. So how it is
yes.
differentiating? Okay, this part of data should go to YouTube tab. This part of data should go to banking tab. This part of data should go to Netflix tab. So there is a beautiful mechanism behind it, which is happen under a session layer.
Okay.
Okay, how it does? It is using something called port numbers, and these port numbers, there are two different things. One is a source port number,
Hmm.
and one is a destination a port number.
Okay. Is it the same like the MAC address,
Exactly.
like destination and what you call it? Yeah.
Uh, 1 minute. Yeah, it is something similar to that, but actually here why it use source port number and destination port number is because let's say that okay, this YouTube, for YouTube server, let me give some IP address, something like 1.2.3.4. This is the IP
Hmm.
of the YouTube server, what you're trying to reach. And for
Hmm.
backing, let's say that 2.3.4.5 that you're trying to
Hmm.
reach. And for Netflix, let's say that this IP of 3.4.5.6. This is what the IP of the destination address. So in this case, there are different things actually. Uh, we know, like in application layer, we have studied a different protocol, right? One is like HTTP, something like HTTPS and
Yes,
TFTP,
I see. Yeah.
FTP. Like these protocol, all protocol, they have some value, okay, which are like
Hmm.
well-known, mandatory, which is been globally declared, which cannot be changed,
Hmm.
and that is what that we need to use it. So what is that value? Is like that numbers we'll call it a port number. So for FTP, the
Okay.
port number, if you ask, it is 21. And there is
Right.
something called a telnet. Okay, for telnet, actually we'll use the port number called 23. And
Hmm.
if you use something SMTP, simple mail transfer protocol, then its port number is 25. Okay, and if you use something the HTTP, its port number is 80. And
80.
if you
Okay.
use HTTPS, then its port number is 443. And
Okay.
for
Because sometimes I
TLS,
see for HTTPS, right?
mhm,
Hypertext Transport Protocols, yeah, secured.
yeah,
Um, at the moment you put 443, sometimes when you're trying to reach the website and the website is not there, it gives you error code 404.
yeah, exactly, right? And let's say that if there is something authentication that it requires, and if you are given wrong authentication, it will return you the code called 401
Yeah, yeah,
unauthorization.
401. Yes.
It is something
And
similar to that.
to that,
And
yes.
yeah, and for DNS, it is 53. And these are the things that you need to at least memorize. At least you'll
Memorize.
be,
Okay, okay.
yeah, you need to handle these things. Might be you can expect these questions in your interview also.
Interview.
Okay,
Okay, okay.
So these are the ports what we'll call actually, well-known port numbers.
Well-known port numbers. Okay. I'll write them down later when Abdul send
Yes.
me the video. I'll write them and then start memorizing.
Okay. So actually, okay, is there any range for this well-known port number? Yeah, so there is a range from 0 to 1023 is a range for well-known port numbers.
0 to 1023.
Yeah, 1023. So this number cannot be seen anywhere else. These are reserved for these protocol purposes. Only we
Okay.
know this many are there. That means which are commonly used, but
Okay.
there may be many which we don't know in common.
Okay. Okay.
Okay, and there is something called registered port numbers. Actually, from 1023. Sorry, from 24 to 65535. Okay, these
Okay.
are called as a registered port numbers in
Registered
common.
port numbers. Okay.
Yes. Okay.
And these port numbers don't change, yes?
Uh, it change. See, well-known port number it doesn't change. For HTTP, it is going to be always 80.
Okay. Okay.
HTTPS it is
Right.
yeah. But why these two things? It will get relevant to here this topic. Okay.
Okay.
So this
Right.
source port number actually, when you are making a request from your laptop to a YouTube
Mhm,
server, you are making it right. And
mhm,
so how do you construct data actually? So your let's say that your source machine got the IP address something like 10.0.0. Some 50, and with the
mhm,
MAC address AAA.
mhm,
So how do you construct a packet if you want to send? So here the destination IP address it will be 1.2.3.4, right?
mhm,
And your source IP address it will be 10.0.0.50, right? And
mhm,
destination MAC address, let's say that for YouTube it is YYY,
mhm.
and your source MAC address it is AAA, and what you're trying to send the data. Okay, only this much actually we have been seen in
Mhm.
past. But including this, okay, if I want to bit explain, this IP are part of network layer and this MAC address are part of data link layer. Actually, this is the payload what you are sending. So in that, something like similar to that, in session layer, okay, you'll be sending a source port number and then it will be a destination port number will
Okay.
be present inside that particular payload actual data. So
Mm.
this source port number it get always changed. It is randomly generated source port number from your CPU. Okay,
Mm.
so that will be generated between in this range from 1024 to 65535. Okay,
Which
so
is
let's say
registered
that
port numbers.
sorry.
Which is registered port numbers.
Yes, right.
But it changes between 1024 to 65535.
Yes, right. So let's say that, for example, I have taken the randomly generated source port number is 10,000 for YouTube when you have initiated the request. And so the destination will be what? Port number will be what? So YouTube uses HTTP protocol, let's say that. Okay. So it
Mhm,
uses 80, right?
mhm,
So
mhm.
the destination port number will be 80.
Okay.
So let's say that if the same thing you're constructing for the banking, how your data looks like, the destination will be 2.3.4.5, right?
Mhm,
And the source IP it will be same again 0050, and destination MAC address since it is banking, let me just give like BBBB,
mhm,
and your source MAC address will be AAA, and the data what you are trying to send. So this is the payload actually that you will be sending.
mhm.
But inside some of these data, let me what it will be the source port number here. It won't be 10,000 again, right? Now 10,000
Oh.
has been reserved for the YouTube.
Mm. So
So if I use the same 10,000 here, there will be some
conflict.
yeah, conflict. So CPU
Mm.
won't understand, okay, this data is for banking or YouTube. So I need
Mm.
to use something else than 10,000 randomly generated. Let's say that it is 10,001 as per
No one.
like from my buffer, okay,
Mm-hmm.
which is free for me to use.
Mm-hmm.
Now banking use what? HTTPS, right? So my destination port number will be what? 443,
443.
right? So let's say that instead of Netflix, let me use FTP, file transfer protocol, the server within my same organization. In that case, I'll use the destination port number as what? 21, right? So any difficulties in understanding this?
It's okay. It's making sense.
Okay. So this is the request actually that you have sent it to the internet over the to the web servers over the internet. So actually when you get the reply back, exactly how there will be a change in the source IP and the destination IP and the source MAC and the destination MAC, how source become destination and destination becomes source. In the same way for the port number as well, there will be a change. When YouTube respond to me from here to here, then my source port number will become 80 and my destination port number will become 10,000.
10,000.
Okay.
Okay.
Similarly for the banking, when the source port number it will be 443 and the destination will be 10,001. Right. So when this reply is reached my laptop,
Mm-hmm.
okay, when it reached my laptop, my CPU knows that okay, this particular port number I have been assigned this to YouTube, right?
Mm.
So this data will be transferred to this particular tab of that browser,
Mm-hmm.
and this data will be redirected to where? The banking tab of your browser.
Mm-hmm.
So this session, what it is doing, it is tracking of all your communication, and it is maintaining. Actually, the three things it happens. Actually, it helps us to initiate a communication,
Mm-hmm.
and then to maintain the session, initiate a session or communication, whatever it is. And then second thing is maintaining a session. That means the conversation, the communication, what you are doing with the remote and servers, whatever it is, YouTube, banking, Netflix. And then also it will help for the termination. Why? How I'm telling is, let's say that you have closed this YouTube tab, so you are
Mm-hmm.
not using this YouTube anymore. Okay,
Mm-hmm.
so until it is in use, this particular port number is being reserved for this YouTube and it is not given to anybody else. When this port is
Right.
closed, now this port will be released from the buffer for the further use. If any other tab
Okay.
is coming in for the new
Coming
request,
in.
then that
Okay.
will be used. So it will help us to initiate a session, and it will also use us to maintain a session, and also it will help us to terminate the session.
Mm-hmm.
So this is what actually the the session layer do.
Session does.
Yes.
Okay.
Any doubts?
No, it's okay.
Okay. So the next one is like now the transport layer. So we have completed the upper layer. Now we have started with the lower layer. So in transport layer, actually we have two different protocol. The major protocol that we should know. One is a TCP protocol, and one is a UDP protocol.
Okay.
TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol.
Okay.
Transmission Control Protocol. and UDP stands for user
So
data
datagram.
protocol. Basically, okay. Now let's say that there is a sender and there is a receiver. Okay, if sender want to send some data to receiver, okay, he won't send directly to the receiver. Okay,
Okay.
so if he is using transport protocol as a TCP, before
Mhm,
sending a data to the receiver, first sender will ensure that, okay, uh, who is my receiver and what is the capability of him, so that how much data that I can send at a time to him so that he can process it, because I don't want to overload him by sending a huge data. So all
mhm,
this something like prerequisites or something like pre sanity checks it will do in background before sending the data. So
mhm.
what we'll call this process as a three-way handshake.
Okay.
Okay.
Yeah.
So first sender will send a synchronize and okay, let me type. This is a synchronized message, and here we'll get sync ack synchronize plus acknowledgement, and
Mhm.
here acknowledgement. And here is my sender and here is my receiver. So here in sync
Mhm.
actually sender is telling that, okay,
Mhm.
uh, he's trying to send certain amount of or certain bits of data, and now receiver will get that synchronized message, and
Mhm.
if that is okay for this receiver, let's say that it is sending some like 100 bits of data per second.
Mhm.
If receiver is able to handle that 100 bits per second, then he'll
Mhm.
acknowledge that, yeah, I can handle that, something like that. If he cannot
Okay.
handle that, he won't be acknowledging that. So like that, he'll be if it is not acknowledged, then he'll be keep reducing the data rate and he'll be trying to send it again to the receiver. And
Mm.
also now what receiver is sharing his capability to the sender with a
Mhm.
synchronized message,
Mhm.
and whether sender is capable of like let's say that I have a powerful machine here which is like with 1 TB memory and 32 GB RAM, but here I have just the small specification computer, something
Mhm.
like 2 GB RAM with
Mhm.
250 500 GB of hard disk.
Mhm. Mhm.
So you know the difference. He can handle more data per
Yes.
second or based on the time frame, and
Yes.
he cannot process us comparatively this guy,
Yes.
right? So this is what the mutual agreement they'll come into it using a three-way handshake. And once the sender is okay with this sync message, what's sent by the receiver, now sender will send the acknowledgement message back to the receiver. I'm okay with that. So
Mm.
once this three-way handshake process is successful, then the actual data transfer begins from sender to the receiver and also
Receiver.
from the receiver to the sender.
Okay.
So before sending the data, they are getting into the process called three-way handshake, where they are negotiating, like what are their capabilities and how much data that they can handle at a time, and
Mhm.
these kind of things.
Mm. So it's similar to like when I'm sending something on my flash drive, yes. So like let's say if I have 2 GB worth of information, me
Mm-hmm.
as a sender, if I'm sending to the receiver,
Mm-hmm.
is that why sometimes that two gigabytes of information
Mm-hmm.
Sometimes, if your computer is very good and very powerful, it will send it very quickly. And
Yes.
sometimes, if it's the other side, it's not very strong, then
Mm-hmm.
you will see it going slowly, slowly. But what you are trying to say here is, if
The
it's
same.
2 GB here, it will
Mm-hmm.
send a sync message, as in, hello, I'm sending you 2 GB worth of information. And then
Okay.
receiver will then send acknowledgement sync back that yes, I can handle 2 MB. Or if he can't handle, it will then send acknowledgement as you can only send 1 MB every time because I can only handle 1 MB. And then sender would then say, okay, I've acknowledged and now I understand I have to send only 1 MB, not the whole 2 MB. Is that how it is working? Three handshake.
Yes. Right.
Right. Okay.
Okay. And also like so this happens in TCP, which is we call three-way handshake protocol, and
Right.
there is no three-way handshake in UDP. That means the
Right.
sender doesn't care about the receiver, whether I want to check with him whether he is capable of receiving it or what. No, he directly send it whether he's going to get it or drop it. He
Oh,
sender doesn't care
why
about
is
the
why is
receiver.
that? Why is that?
Then why such protocol that is in practice? That is what your question, right?
Yeah.
Okay,
Why
it is
he doesn't
something.
why he doesn't care? He has to care.
See, even like let's we are doing a WebEx and we are speaking each other. There
Yes.
might be a few data. That means the message what I am saying may get dropped,
Yes.
right?
Okay.
It
Okay.
is not necessary that need to be retransmitted to you.
Oh,
If
okay.
all the dropped message are getting retransmitted to you, you may not be getting in that proper way how it is
Wait.
supposed to deliver.
Okay.
So it is based on the application that we use, right?
Use. Okay. So
So
TCP will do that. It will make sure the receiver will always receive what they need in the
100%
right
data
way,
guarantee.
exactly in the right way by having the three handshake. Whereas UDP doesn't care whether you receive it or not.
Yeah, yeah. He is just like a dumb fellow. I'm just throwing to you. You catch it or drop it.
Yes.
Okay, so I
If
can
you're
say
not
there is a
strongly.
data guarantee in
Mm-hmm.
TCP.
Mm-hmm.
Uh, there is no data guarantee
Right.
here. So actually, how I can say TCP is data guaranteed? Why? Because whenever I send a data to a receiver, okay, for that particular data, receiver need to acknowledge back to me. Let's say
Yes.
that I have five this is sender, this is receiver, and let's say that I'm sending one data. Okay,
Mm-hmm.
now receiver need to acknowledge back to me stating that he got this message.
Yes.
Then only I'm going
Before.
to send the next data.
Yes. Before receiver send again. Okay.
Exactly. Okay, so there is a concept of windowing. Okay,
Mm-hmm.
so
Mm-hmm.
that means for how many. Okay, just think of it. If they started doing in this fashion, how long the process does it take to complete the, communication, exchange of the data? So it may take too long, right? So
Mm-hmm.
that's why there is a rule called windowing has come. Okay, you don't want to acknowledge for every packet or every flow, but instead of that, okay, every three flow that you acknowledge to me, that means like, okay, let me send you three packets, something like this, one, two,
Mm-hmm.
three. Then you
Mm-hmm.
acknowledge you, okay, uh, let me
I
just
can
type it
handle.
here.
I can
This
handle
is
three
one,
three
two.
packets.
It is, no, it is not about the packet. That is only about the size of the data, what I referred to. It is a flow, right?
Right. Right. Okay. Okay.
Okay. Okay. When it's send number one with a sequence number, there is something called sequence number when it's send data in
Mm-hmm.
TCP. Okay, number three here. Now, how the acknowledge goes is like it will expect the four. This is just for example I'm telling you. Okay,
So when it send the three, is
yeah,
expecting the fourth one.
yeah. Now it starts sending the four and then five and then six. Now it
Six.
will say that okay, send me the seventh.
Okay.
If there is a seventh, then it will send. Otherwise, he won't send.
Okay.
Okay.
So that is
So
called
actually,
windowing.
yeah. So this everything, whatever I have told you, based on the sequence number, that is the number, right? But
Hmm?
actually, the acknowledgement will not be based on that sequence number.
Sequence number. Okay.
Okay, they always based on the number of bytes that it has received. Let's say that I have sent you 100 bytes of data here, and
Hmm?
let's say that I have sent you here 100 bytes of data, and let's say that
Hmm.
here I have sent you 100 bytes of data.
So that's
Then
300
now,
bytes. Hmm?
yeah, now it will look for 301. That will be the acknowledged number.
Yo, okay.
Okay, this is just for your simple understanding that I have told you, but it is not the exactly same way how it is going to send the acknowledgement.
Okay.
Okay. So
Yeah.
always the acknowledgement is based on the number of bytes that it has received.
Okay.
Okay. So this is why I say date. Okay, I haven't completed it. Let's say that in that case, this particular uh, three is not received by the receiver.
Hmm.
Okay. Now what will be the acknowledgement that it sends? Okay. Instead of four, it will just send three, thinking of that only one and two it got received. Right? So
Hmm.
what this sender do? Okay, it is acknowledging for three, not for four. Might be he didn't receive the three. Okay, let me
Hmm.
transfer that to that sender. Sorry, receiver,
Hmm.
so that receiver can get that. Suppose in that case, let's say that if receiver got one and three, but not two.
Hmm.
In that
Hmm.
case, he'll not acknowledge for four or three. He will acknowledge for two,
Two.
stating that I have
Okay.
received one and three, but
And
I haven't
three.
received two.
Two. Okay. So
So
then the
two will be
receiver can
retransferred.
resend. Yes, will be retransferred from the receiver back to that one.
Exactly.
Okay.
So this is why we are telling TCP is data guaranteed.
100%. Yes. Yes.
Okay, but
Yes.
it will not happen in UDP.
Okay.
And okay, so let's say that for each and every time, John, did you get understand what I say, what did I say, or whether is there any doubt? If I keep asking this question to you for each and every word what I used to say, you may get irritated, right? Or like there may be the session, let's think like I have planned for 30 minutes. Only for this confirmation it will take 10 to 15 minutes,
Mm.
right? For each and every time if I ask the same question to you. So what
Mhm.
I do is like it is like payload is higher and it is slower than UDP. Okay, it is
Okay.
slow. TCP is slow. Why? Because it's expecting the acknowledgement for every packet or every
Everything that
flow.
sense.
Yeah,
Yes.
that is why it is slower than UDP. But UDP never care about anyone, so it's just
Right.
faster. Okay.
Okay.
Uh,
So that means with TCP, it's always 100% guarantee because it will make sure that the receiver has received everything
right.
before it closes down.
Right.
Whereas, and in that case, it becomes a bit more slower in
Yeah.
terms of data transfer. But
Yeah.
UDP doesn't care about acknowledgement and all that. It will just send it. Is if you receive, you receive. If you don't receive, you don't receive. So, in
Right.
other words, UDP is more faster.
Right.
Right.
And also the payload, actually the data is actually it is high in TCP and it is less
TCP,
low
less
in
in
UDP,
UDP.
right?
UDP.
Yeah.
Okay.
So actually, like that I'm sending data, and for that I'll again then receive the acknowledgement, but which is not happening in the UDP. So the actual
Mhm.
payload will become high.
Right.
Okay. So this is what actually the difference between the TCP and the UDP protocol.
Okay. Okay. I kind of like get it now. So, okay. So you would say UDP is used more for things like mobile phone and things, yes? Like talking.
Exactly. Yeah. Yeah.
Because
You
that,
get
that
that.
that one doesn't need any acknowledgement. It's just, having the speed to be able to talk so that it doesn't
Yep.
drop.
Right. You
Okay.
got that.
Right.
Yeah.
Right. Right. Right.
And also in transport layer, there will be something called uh, error checking happens.
Error checking.
Actually, error correction. If you read
Correction.
any of the
Okay.
books, they'll
Mm-hmm.
say that error correction happens at the layer 4, but technically nobody can correct the errors, right? If I'm sending something to you and you suspect that it is not the way it's supposed to be, then you cannot correct it by your own, because I am the owner of the data. Only you can
Yes.
detect if there is something errors.
Okay.
Okay, so technically error correction is not possible, but if you read any of the books, then in some of the books they have mentioned like error correction happens at transport layer, but technically it is
Okay.
only error detection.
Okay.
Okay, so
So
what is the
suppose.
mechanism they use is something called a CRC, cyclic redundancy check.
Okay.
Okay,
Check. Okay.
so actually, what happens? Okay, regarding this error connection, detection, I'll just explain once I done with the OSL layer. There is something else I need to talk. Okay, so in this, that's what I want to say about transport layer. So here, usually, like in network layer, we use the protocol is IP, Internet Protocol. In IP, there are two versions: IP version 4 and 6.
Okay.
And we'll talk about like more about the network layer and their IP protocols in the routing section. If we cover that, you might be forgetting that. If I start with a anyhow, I need to repeat that again in that routing chapter. So I'll cover what is the network layer. Basically,
No
network
problem.
layer checks like what is the destination IP address and what is my IP address, whether it matches, whether the data what I have got it is for me or not, like how we have
Okay.
checked in that last session.
Yeah.
The checks,
Application.
it will happen at the network layer. Okay, and the data link layer, actually it has two sub layers actually. One is, we call this as MAC, media access unit, and one is LLC, logical link control unit, media access control, media access
The access
control, and
control.
logical link control.
Logical.
Control. Okay. So these are the two sublayers within the data link layer. So what MAC, that media access control layer, does is like when the data is being received through a physical media to the device, right? In data link layer, it checks whether the destination MAC address is getting matched with its
Okay.
own. Okay,
Right.
if it is good, then it will record that, and then it will look, okay, from whom that I have got this data, what is the source MAC address. Then again that will be recorded in its memory, and then in that data will be given to the LLC in logical link control unit. The decision making happens. Okay, I got this data at LLC layer. Okay, this data is sent it to where, because there are multiple protocol in my upper layer. What is the upper layer of the data link? It is a network layer. There are like IPv4, IPv6, and so many protocols are there. So to which protocol I need to hand over this data, either IPv4 or IPv6 or whatever it is. Okay, the protocol. So that decision making will be happening at the logical link control layer.
So from network, once it's checked the IP address, which is IPv4 or IPv6,
Hmm.
then it will send it to the physical. Yeah, layer. Yes, and then the
No,
physical layer would then check the logical link
no,
control.
no, no,
Yes.
no. In physical layer, there won't be any checks. Okay, in physical layer, there is nothing is there. Expected physical components like hardwares and cables, connectors,
Right. So okay.
right?
So end to end point. Okay. Right.
Yeah. So these two sublayers, what we have talked, it is within the data link layer.
Data link. Okay. Okay.
Yeah, both or sublayers of the data link layer.
Right.
Okay.
But the
In
network only deals with the IP addressing. Yes.
yeah,
The
yes,
protocols. Yes.
right.
Okay.
In data link layer, there is no IP protocol. Here it is a MAC protocol.
Okay.
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 So this is the only
So
layer that you can.
when you say MAC protocol in data link,
Yeah,
is that like how do I say it? Something like a MAC table? That's where it stores all the information.
exactly. Yeah.
Right.
So
Right.
do you have any experience in networking?
Not really, no.
Okay. So how do you know about this MAC table?
I used to repair computers, and I used to deal a lot with softwares. I
Great,
used to
great.
what do you call it, like clean computers, like
Okay,
what you call it,
okay,
viruses and operating system and that sort of thing. So yeah,
great, great. Okay,
it's just
that's
that
nice.
with networking is slightly different. So this is why I want to learn, because the terminologies and all these things is all different. But I think it's
Okay.
similar now. Now that you're explaining, it's clicking my brain. Like it's kind of like similar to how we repair motherboard and all these things. Information goes through here and that sort of thing. So yeah,
So basically, it is kind of a system admin role what you are currently in.
yeah.
Oh, great. Okay. Okay. So this physical layer is the only layer that you can touch and feel in the OSA layer. So rest everything is something like virtual. You cannot see like how the data is passing through the wire, something like that.
Okay.
And again, there is error detection happens at data link layer.
Oh, okay.
Okay. So let me show you that. Here something called frame check sequence happen.
Frame check sequence.
Again, actually, yeah. Again, I'll explain this how they will do it. Uh, so this is what about the OSA layer that I want to talk. Let me just erase everything, and we have few more parts to cover in OSA layer. Actually, how they send and receive the data at the sender and receiver end. So quickly, I'll just write all the protocols. Sorry, all the layers: physical,
Yeah.
data link, network, transport, session, presentation, and application. And let me just
So this thing you write, I have to memorize that one as well, yes? And the port numbers
exactly.
as
I
well,
gave you
yes?
the keyword, right? Sorry,
Yes.
code words. That how you
Yes.
can memorize this. Do you remember that?
Yeah, I watched the what you call it,
Okay.
the video
So
Abdul said. Yes.
okay.
So TCP
So this is sender and this is at the
receive.
receiver end, and we are connected through some. Let's consider it's a wired media at the physical layer. So the one thing like the data are we have just told like there is data something it will be processed at each layer, right? So being a
Okay.
network administrator, you need to know there are few how to say that there is something called a protocol data unit. Okay,
Okay.
protocol data unit. Like how will we have unit for like current as ampere, something like that. We have a unit for these data which work at different layers. Since we are
Okay.
not working on these upper layers, okay, we don't want to classify anything for this data. So in simple terms, actually, we are calling this as a data.
Oh,
And for
are you there?
transport, sorry, Hel-
Hello?
yeah, John.
Hello? Can you hear me?
Yeah, yeah, I can hear
Oh,
you.
I
Is there
didn't,
any
I
trouble?
didn't, yeah, I didn't hear you. You were talking, but I didn't hear.
Okay, 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 fine. Okay, since we are not working on this upper layer, application presentation session layer, we
Hmm.
categorized the whatever the data is being processed within the layer simply as data itself. We are not giving any name to them.
Okay.
But if there is a data processed within the transport layer, so we have seen two different main protocols like TCP and one is UDP.
UDP
So if it is being handled by TCP, then those are called as segments. Those
segments.
data
Okay.
are called as segments. And
Segment.
if the
Okay.
data is handled by UDP, then
Hmm.
that data is called as datagrams. Use a
Datagrams.
datagram
Okay.
protocol. So datagram. The data unit is
Okay.
called as datagram. And TCP
Right.
data unit is called as segments.
Segment. Okay.
And here for network layer, we are handling with IP. Usually you
Yes.
might be hearing IP packets, right?
IP
So
packet. Okay. Yeah, I
yeah,
heard about packet. Yeah.
yeah. So packet
So
is,
that's done on the network
yeah,
layer.
it is on the network. And in
Okay.
data link with the associated with the MAC protocol is we call that as a frames.
Frames. Okay.
Frames. And there is no PDU for the physical layer since we don't deal with any of the data. It is just a physical media to just send and receive the data. Clear?
Yes. So anytime you hear segments, you know it's on the transport layer. Datagram is on the transport layer. Anytime you hear
No, no,
packet,
no. Segment on transport layer by TCP.
yes, by
Datagram on
TCP,
transport
yes,
layer by UDP.
UDP. And
Yeah,
then anything to do with packets is on the network layer.
right,
And then anything to do with frames is always on the data link layer.
right, right.
Okay.
So in this case, okay, and one more thing that you need to keep in your mind is like whatever the data is being processed by each layer, only that particular layer at the receiver end can understand what it is. Something like if you're speaking French and only the French guy can understand what it is. If you're speaking Spanish, only the Spanish guy can understand what you're trying to say. Something like that. Okay. So if there is a data is being handled processed by presentation layer, only this presentation layer know what is that data it is and
Okay.
how I need to look into the data and what does it mean. Okay,
Right.
so they
So
are layer
presentation
specific.
layer specific. So when you send something, presentation will acknowledge on the other side presentation only. Application will
Right,
acknowledge on the side application only. So
right,
they can't overlap. Like network layer is gonna go and check out presentation. It doesn't work that way, is it?
correct, correct.
Right. Okay.
So
All
what
right.
happened here is in application layer, actually user we are the user. In browser we are going to and we are sending our data something like
Yes.
www.google.com. So that is the
Mm-hmm.
data, right?
Mm-hmm.
To get that Google web page.
Yes.
So
Yes.
simply I mentioned a data.
Yes.
So once this data is being sent down to the presentation layer, so what presentation layer does is he'll just look into the data. He's not going to do anything with it, but he'll see what protocol it is. It might be HTTP, HTTPS, whatever it is.
Right.
And according to that, it will process something on this data and he'll add something called header. Okay.
Okay.
And since it is layer 6, Let me mention this as a layer 6 header.
Header. Okay.
Yes. He will put all the information in that header only. So this complete data is being encapsulated by layer 6 header. It
Okay.
is encapsulated.
Encapsulates. Okay.
Okay, that means it is with it has like completely encrypted with that particular layer 6 header. Now the data is within the layer 6 header.
Okay. So from
S-
application, it
Yeah,
will then send it on to presentation. Presentation will look into it and put a header onto that data,
yeah,
whether it's HTTP or FTP or whatever. Yes, it will put that header on it. Yes.
right.
Okay. Mhm,
So now what happens? You just assume that this is a complete data given to a session layer,
mhm,
right?
mhm.
So now, what should be the data received by the session layer? He doesn't know what it is there in.
Oh, okay.
So data, and then there will be a layer
He's gonna.
6 header, and there's a whole data that he got received. Now he know like whether he need to initiate a session or manage the session or terminate the session. Based on that, he'll include something like a port numbers, like source port number, destination port number, all this
Okay.
information under layer 5 header, and he'll encapsulate that particular data.
Oh, okay. So one after the other, they will add their own layer header on there. Yes.
Exactly.
Right. So each session is basically adding a layer header on there and then encapsulating the information from the one he got from. Yes.
Yes. Basically, that header contains like which is associated to that particular layer. If it is a session
Layer.
layer, they'll have about the port number details. If it is a
Yes.
presentation layer, they'll have about how I need to encrypt and decrypt based on which
Yes.
protocol that they
Yes.
have. So in transport layer, so what will be the data that he will be getting from the session layer? So he will be getting data which is already encapsulated by the layer 6 header,
Mm-hmm.
again which is already encapsulated by the layer 5 header.
Mm-hmm.
Okay, this one complete data which will be received by transport layer.
Mm-hmm.
Now transport layer, what he'll look, okay, what type of connection that I'm going to
To transport
request
with.
the receiver. Yeah. Do I need
Yes.
to expect the acknowledgement for every data what I send, or there is no acknowledgement required? Something similar to TCP and
Yes.
UDP.
TCP, UDP. Mm-hmm.
Yeah. So that information will be put under layer 4
For
header
four.
file.
So it's adding his own header on there as well, and then encapsulate to send it to network layer. Okay.
Yes, right.
Right.
So
I'm
now
getting it.
network layer got the actual data from the application and layer 6 header
Yeah.
and
Layer
then
five,
layer 5 header
five,
and then
and then
layer
layer
4
four,
header and then layer 3 header.
layer three header, his own layer. Okay.
Layer 3 header, it is not at. So now the layer 3 header will come,
Yes.
which contains what is my source IP address and destination IP address.
Destination IP address. Okay.
So this is what the whole process here it takes. But in data link layer,
Hmm?
uh, we'll get a data and also layer 6 header,
Yeah.
layer 5
Five,
header,
layer four,
layer 4 header,
layer three.
layer 3 header.
Yeah.
So apart from that, there will be two different things. One is,
Two different things.
yes,
Mac,
it is not
Mac.
only about the header.
Hmm?
Yeah, that is that information MAC address. Source and destination MAC address will be
Mhm.
in
Added
L2 header.
header. Yes. Layer two header. Yes.
Yeah, and also
So
here you can see something called a trailer as well.
the trailer.
Yeah,
Oh, okay. So it's adding
L2
one extra after the
trailer.
header.
Yeah, sorry, I don't have space here, so just I'll mention a trailer. Okay.
You can put after layer two. I will understand.
Okay, but actually the format
Yes,
should be something like this.
shift the data one a little bit back, and then you have a little bit more space in the front. Yeah, that one shift back a little bit. Yeah, that's it. Push it back. Yeah, that's it.
So layer to trailer. So why
Yes.
trailer is, I have told you, error correction detection will happen at two layers in OSI, one at data link layer, one at transport layer, right?
Right.
So in data link layer, I have told the mechanism something called frame check sequence will happen.
Mm,
And in layer 4, I have told something like cyclic redundant check will happen.
yes.
So for that checksum, for that error checking, this layer 2 trailer got added. Actually, what they do is like they will be processing completely, like in this case, now L2 processed the data given by the network layer and he added its own layer to header and also layer to trailer. That means during the processing of the data, they'll come up with a value, something called a checksum value.
Checksum. Okay.
Yeah, so this is something kind of passcode sent by the sender. If this is the same for you as well, when you're processing this data is good. It is not interrupted in the between while sending.
Okay.
Okay, so this checksum value should be good. Okay, so when this data is being received at receiver, now what receiver will do? Let's say that this data is sent over physical media. It received at this physical media, and now it is sent it to the data link layer. Now this data link, what it does is like he'll check at the layer to header. First, it will verify whether it has come to the correct MAC address, destination MAC address. Let's assume that that is good. Then it will see who is the source MAC address, and it will record that. And what he do? Uh, he'll go for something called a checksum. He'll do checksum calculation, and
Mm-hmm.
he'll compare the checksum added by the sender and
If
actually
it's the
what
same
it
data.
got come up with.
Mm.
Okay, if that two checksum value got equal, then this data is good. So what it does, it remove this particular header and it remove this particular trailer,
Mm-hmm.
and this data will be sent it to the network layer.
Network layer. Oh, so in other words, if I understand what you're trying to explain to me, from the sender, all from application, presentation, session, transport, network, and data link, because physical is
Yeah.
just physical wires, nothing is there. So when we get to data link, basically one after the other is being encapsulated, yes? But when you send
Yes,
it to the receiver, it's going to de-encapsulate everything going up again.
exactly. Right.
Right, I get it. I
Encapsulation
get
happen
it.
at the sender end.
Right. And
Decapsulation happen at
de-encapsulation,
the receiver end.
receiver end. So it's
So
going to unwrap everything. But
yeah,
for the data link, it will remove the first two, what you call a header, to do the checksum to make sure it's correct before it sends it up to network, transport, session, presentation, and then application. Yes?
yes, right. So
Right, right.
finally, the user will get the data, which is without having any header, which is in the readable format,
Yes.
right? So this is how actually, the communication happened from the sender and the receiver. So encapsulation
Right,
happen at sender end, decapsulation happen at the receiver end.
right. Okay, okay. So this is what we call OSI model, yes?
Yes, right. So similarly, how the checksum is being verified in data link layer is also will be verified at the transport
Transport
layer
layer,
as well.
network
Okay.
layer, session
So here
layer.
also they'll have something called a checksum, right? That checksum also it should be matched at the transport layer. Let me
Mhm.
quickly show you some, you know, ether. Ethernet header format. So this is how that header format looks like actually at the layer 2. Ethernet means actually layer 2.
Ethernet.
Ethernet, yeah. So you see here, so there is something called frame check sequence, right? At the end. Is it visible for you?
Yes, yes.
Yeah. So this is actually where the checksum value will be kept for the layer 2 at the trailer end. Okay.
Okay.
And if the same thing, if I want to show you like for transport layer, then you need to check it TCP header format. TCP IP header format. So you see here, there is a checksum value here in this header.
Mm-hmm.
There, there it was in layer 2, it was frame check sequence. Here it is
Mm-hmm.
just a checksum,
A
the
checksum.
field. So where the checksum value will be put and it will be compared. If it is same, then they will consider the data is good and they will, if it is not good, then they will just discard it.
Okay.
So if the checksum looks good at layer 2, if the checksum is not good at layer 4, then at layer 4 the packet is discarded
It's gonna
and
drop.
requested
Okay.
sender to resend the data.
Resend it again. Okay.
Yeah. So that is what it happens. So the other thing, like I just wanted to go through cable types. Let me just remove this. So once we done this, then tomorrow we can start with switch.
Okay.
How to, what is switch, what is hub, how to configure that. We can see some practical stuffs. So cable types. First, I have told you there is a coaxial cable. I don't know, like in London, like how the setup it will be for the television, but in India, actually, for every set-top box, there will be a backside. There is one thick a cable will be there with the copper film in the middle. So
Yeah,
basically,
we
that is
use we
used.
use I repair satellite myself, so we have
Okay,
the satellite cable, so it's got a copper in there with the
exactly the bulky one cable,
enclosure on.
right?
Yes,
One
yes.
single
You have
cable.
yeah,
Yes.
one single cable with three layers, I think. You have the white layer, and then you've got the copper around it, and then you got another layer
Yeah.
on top, the layer on top of it. Yes.
Yes. So basically, that is a coaxial cable that
Correct.
we
So
can use it for this television streaming,
yeah,
all these purposes.
free to air on all those things. Yes.
Yes. So basically, I think they'll use something like a frequency division multiplexing mechanism, like like
Yes.
in one channel, sorry, in one cable, we are receiving like maybe 100 and 200
Yes. Yes.
channels.
Channels.
Just by
Yes.
increasing and decreasing the frequency levels, we can tune to that particular channels by the remote.
Channels. Yes.
Yeah.
Yes.
So basically, what they are doing is like frequency division multiplexing technology in that. And the second thing, like we are using something called a copper cable. Basically, even coaxial cable. Okay, uh, I need to type here a copper cable. Okay, in that A, which is coaxial cable. And the second thing, actually, we have something called, like Ethernet cables, which are Cat5 cable or Cat6 cable, Cat5e cables. There are multiple versions, which are normal over the LAN. Some people will refer to a LAN cable or Ethernet cable, whatever it is. So
Okay.
in that, actually, we are having two different types. One is like shielded,
Mhm.
shielded twisted pair cable, and the other one is
Unshielded.
unshielded twisted pair cable.
You check on the when you finish typing, could you go on Google? Let me see how that one look like.
Sorry?
I said when you finish typing, can
Yeah,
you
yeah.
go on Google? Let me see a picture of that one, how it looked like.
Yes, yes. Okay. So, okay. So basically, the shielded twisted pair cable is something like you can see there is shielding with a copper film. It is not a
Yes,
copper film. Yeah,
yeah.
there is a foil shielding will be done.
File, yeah,
Uh,
yes,
yeah, right. But
yes,
in unshielded twisted pair cable, there is
yes.
only a outer rubber coat is there,
Oh, rubber,
but there
yes,
is no foil shield is there.
yes, yes.
And you see there are eight cables in that each cables inside there in each wire. There are eight cables inside to that, which are twisted like every two cables get twisted each other.
Twisted, okay.
Yeah, is there any reason that they are doing it, or simply to do time pass, or
Mm, from what I know from my repairs, like
Mhm,
the normal LAN cable that we
mhm,
use, normally when they are setting up the internet, they will use your telephone line. And the
no,
telephone line one, you've got so many different colors of cable. But I think from what you are showing me here, the
mhm.
twisted one makes it faster, untwisted probably slower. That's what I am thinking.
Okay, but maybe it is not right. Why? Because like it does not make sense like in terms of the fast based on the
Okay.
data rate or whatever you are referring to. Actually, the
Okay.
purpose is like let's say that there is a transformer wire or something like that where the current passes. Okay, let's say that the current is passing in this direction.
Yes.
Okay, so by surrounding this wire by default there will be some kind of magnetic field will get generated,
Okay. Okay.
which is we'll call EMF, electromagnetic field,
Field.
right?
Yes.
So this magnetic field have that strong, like they are much capable of destroying the data which we are sending through the voltages. Basically, you know, uh, in our this cable, how we are sending the data in this everywhere using the voltage pulses, right? In copper cable, right? Because they are conductor, they carry the current. So
Yes.
here we are using, the voltage to send and receive the data. So when I'm sending a voltage, basically it is a minute current, right? So
Mm-hmm.
it forms a electromagnetic field surrounding that wire. So what happens? The electromagnetic field generated by one wire, it affects the data which is being carried on the another wire.
Another wire. Okay.
Okay, this is called as electrical interference.
Okay.
Okay, so in order to avoid electrical interference, finally they have come up with a solution
Okay.
called
Twisted. To twist it.
twisting mechanism. Yeah. So
Yes.
when they are
Yes.
twisted this cable, at some point, this electrical magnetic field is getting nullified.
Right.
Okay, so it will not
So
impact the
it's
data
less
which is
it's less interference so that the data can flow through
e-
it.
exactly, so that
Right.
our data which is in terms of voltage will not get affected.
Right.
Okay, so this is why we are calling this as a twisted pair cable. And why we are
Mhm.
twisted is this is the reason behind it, to avoid the
Okay.
electrical interference.
All
So where we can use unshielded twisted pair and where we can use shielded twisted pair.
right. Mhm.
Let's say, okay, I am what a billionaire, and I have like, I want to set up a business everywhere, though there is no means of using shielded twisted pair. I can buy
Yes.
and I can put it just like that. Why? Because I have money. No, it is
Don't
not something
worry.
like that. Okay.
Don't worry.
So
You're gonna be billionaire, man. The moment you say it, you're gonna be. Don't worry. Give yourself another year or so. You're gonna be.
okay, so there is a reason actually why we need to use it and where we need to use it. Let's say that if the company or organization, let's say that you are a network administrator where you are working there, and the complete network is under your control, from everything that cable patching, very well about that. A network is good, and it is a safe for the network. You don't want to worry about any kind of data corruption or something like that. So in that case you can go for a unshielded twisted pair without that foil protection.
Right. Right.
Okay, let's say that you're going to connect a two different office network which are just a few miles away or just few meters away, by using directly laying the cable where you have the permission. But
Mhm.
if this this environment is not in your control, only you have control within within your organization here and here,
Mhm.
but
Mhm.
not here, which is
Here.
outside. There may be a huge electrical generator,
Yes.
or might be a electrical force which affect our
Like
the copper cable.
like poles and stuff. Yes. Like is on the building and those things.
Yes, so in that case, you can go for the shielded twisted pair.
Yes. To
So this
avoid
is,
interference.
yes, this is why, this is how you need to choose the cables where you are working. Let's say that there is like, if you see like there is an industry who manufacture some kind of like airplanes or jets or something like that. Their inside environment will not be that much safe. Okay,
Mm.
might be, I'm not sure how it is there. I have seen few organization, they don't keep their environment well maintained. Might
Yes.
be the cables will be hanging here and there,
Yes,
and
yes. In
might be,
some of the factories I go, is hanging up there. You can
yeah.
see the
So
LAN cable. It's not, they don't put it together. It's hanging
yeah,
here and there.
hanging is fine, not a problem. But if there is kind of if such unsafe condition, then we can better go for unshielded twisted pair.
Yes, yes.
Okay. So these are the parameters that you need to consider for choosing this
Consider
cables.
cables. Okay.
Okay. And also we have something called a fiber cable. Fiber cable. In that fiber
That one
cable
you
we
said
have,
you fiber one last time you said is light, isn't it?
yeah, exactly right.
And well, when I watched your video last time one, I was
Hmm.
doing a little bit research and it said you have a glass one as well, fiber glass.
Right. Actually, it is glass is a medium that they used in the fiber cable. Inside
Okay.
the glass, we are using the light to transfer our data and to receive the
Right.
data. Right?
Right.
So why we are using light is why, because there is a glass inside in it, which is
Right.
very sensitive. You cannot roll, or you cannot slip. How you can do with the Ethernet cable? It will get broke then, and even that fiber cables are very costly in nature.
Mm.
So here we are having two different things, which is SMF or MMF, which stands for single mode fiber or multi mode fiber.
Okay.
Okay.
Can you write it next to it for me, please?
Yes, sure.
Because
Single
before
mode
I forget,
fiber,
single fiber,
single mode fiber, and
fiber,
multi
yeah,
mode fiber.
multi-mode
Okay.
fiber. Okay. Yeah.
So usually, how does it look like? Is like usually fiber cable. Let's you consider this is a fiber, and here. We have something like this. This is inside the cable what I'm talking to.
Oh, okay.
There will be two sections. One is a clad and one is a core. The smaller one, what you are seeing here, this is a core,
Oh,
and
core
the surrounding the core, this area is called as clad.
clad.
Yes. So what happens is like your light signal will enter this core and it will not penetrate through the clad if it is a good fiber. If the standard of the fiber is good. If the standard is bad, then you can see there is a drop which is getting penetrated through the clad so that your signal quality is not that so good. So in this case, if it is a good fiber, it is what it do is like it will get reflected internally. What I'm doing, and it will pass the other end.
When you mean it will pass the other end?
The cable have two end, right? One end here, one end there.
Oh,
Let's say
okay.
that this is from the sender, and
Okay.
that end the receiver is connected.
Okay.
There won't be any signal loss if it is a good clad. This is you can consider a single mode fiber, and if it is a multi-mode fiber, what is the difference is the diameter of the core for the single mode fiber is very small, right? But in multi-mode fiber, the diameter is large, larger than this clad. The core diameter is larger than the clad in multi-mode fiber, and there will be multiple signals will be passed.
So larger signal.
Yes, right. So basically, this MMF will be used for shorter distance, shorter distance, and SMF can be used for long range. And again, like there are it is completely specified to that vendor who is manufacturing that cables and what is the capacity of the cable. It differs from one vendor to the other vendor based on their market standards and how they manufacture it.
Okay.
Okay, so MMF is for shorter distance and SMF is for longer distance. But
Can you can you quickly
yeah,
just go on Google? Let me see how the actual fiber look like, the cable. Just
okay.
quickly see. I'm really particular about the clad you talk about. I want to see how.
Potential up to 200 kilometer that it can connect. Single mode
Which one?
fiber.
Oh, the single mode. Okay.
Yeah, and multi-mode fiber can
200.
cover up to 550 meters.
550. Okay.
Again, it is not defined. It differs
Okay. So
based on
it depends on the manufacturer.
yes, yes.
Uh,
Okay, so this is what the fiber cable it is, and this fiber cables. One minute.
click on image. I think you
Yeah,
did.
yeah, yeah. I have done it.
Ah.
So you see the connectors. How do they look like? Yeah,
Optical fiber cable. Optical
there are
fiber.
different types of connector. Actually, this is how the common fiber cable looks like. Okay,
Okay.
one is A is like transmitter, B is receiver. Same thing
Okay.
here. Okay, so and If the fiber is not working properly, what they do is like they'll inject the laser from here. They'll just
Huh?
see whether they're seeing it from the other end.
Oh, okay.
They'll not see directly with the naked eye. It will spoil
No.
your eye. Don't do that
Yeah.
if you're
Yeah.
supposing, okay, because it's laser. Okay,
Yeah.
just like in fraction of second, you can just see and just move that.
And that's it. Okay.
Yeah,
All right.
okay, that is something called as a light therapy to test the fiber cable. And okay, have you seen any ports something like this to connect in the routers or the switches? No, we don't see
No.
any of these ports. Okay, so how do we connect these ports? Is there is something called SFP,
SF, SFP
SFP modules. Yeah,
modules.
this SFP is a module. Again, it is based which defines how far that this SFP is capable of taking the signal,
Okay.
like 1 kilometer or 500 meter, based on these are the SFP modules, right? So where we plug this fiber cable into that SFP module. This SFP
Okay.
module is being attached to the switch or the
Ah.
router. Okay, these are called as small form pluggable factor.
Okay. Because in London here they use their fiber cable is an actual cable like
Mhm.
coaxial cable, but at the end you have to screw it on the back of the modem.
Okay, okay, great. Okay, basically it is a fiber net.
Ah.
Okay,
Yeah,
so
like you
this is
see like
called,
that cable. You see like that cable,
yeah,
the one before.
this one,
No, no, no.
this
Yeah,
one.
here. Come down, come down. Let me see. Yeah, like this.
Yeah, I understand. I think I have
Yes,
seen
yes.
that.
Yeah,
Yeah,
with the screw. Yeah.
yeah, yeah. Okay. So this was about the cables, and
Okay.
there are a few more cable. Actually, these are based on their physical properties, how we can define the cables. And also, I
Right.
have shown you that SFE module, which is used to connect, fiber cable into our chassis, router
Yes.
or switch.
Yes.
So there are the cable classification that we can define based on which device get connected to which, right? Like
Okay.
console cable, what I have mentioned in our demo class or in the first
Yes.
day, and there are something like crossover cable and straight through
Yes.
cable, something like that.
Yes.
So if you remember the OSA layer, in that seven layer, the the first four layers, first one is what, physical layer, and second is a data link layer,
Data link. Yeah.
and third is a network layer.
Network. Yeah.
So in physical layer we can consider few devices like normal cables or even hubs works under physical layer,
Okay.
or repeaters.
Repeaters. Okay.
Okay, and in data link layer what we can say is like switch and bridges. Bridges are
Okay.
normal, so let me remove, and let me just type switch. And in network layer, just you can have a routers.
Right.
Okay,
Right.
or also you can yeah, routers. So if you are connecting a different layer devices like router to switch or router to hub or hub to switch, in that case you should be going for straight
Mm.
through cable.
Okay.
Okay, and if you are using the same layer devices, router to router, let me just write it here. different layer devices. Okay, if it is same layer device, okay, router to router, switch to switch, then you should use crossover cable.
Router to router is crossover cable. Okay.
Yeah. If the box is new for a configuration, okay, if the box is new, okay, then control cable is used for initial configuration of the box. Initial configuration.
Okay. So different layer devices straight through cable, which is on the
Yes.
physical. Yes, on the
Yeah.
physical. Yes.
Yeah. Yeah.
Okay. Um, on the network layer, router to router is going to be crossover cable.
Right.
Yes. Okay. And then if the box is new, when you say the box is new, is that the router?
Router or
Router,
switch.
okay. Or
Yeah.
switch, okay.
Yeah.
So if the switch or the router is new, then you have to use console cable.
Yeah.
Yes?
For the first time
Okay.
configuration.
For the first time, okay. Can I see, can you go
Yeah.
to
Yeah.
Google? Can I see how
Yeah.
console
Yeah.
cable look like, please?
No, even you can see the difference between straight through and
Oh, okay, okay.
straight through cable versus crossover cable. So there is a color coding actually.
Okay.
Mm, okay. See here,
Hmm?
this 1, 2, 3, 4. There are 8 wires, right? Here also
Uh-huh.
there are 8 wires. This first is connected to first. If it is the same, there is no
Straight
changes.
through. Okay,
Yeah,
so straight through
y-
1 to 1, 2 to 2, 3 to 3,
yeah.
4 to 4
Y-
is straight through.
You can keep the jack facing yourself, something like this, and you can see the codes 1, 2, 3. Whether the color code is same or
Is the
is
same.
there any
Okay.
difference? Yeah. So if you see one is connected to 3 and 2 is connected to 6, in the same way here one is connected to 3, 2 is connected to
That's
6.
crossover.
Rest everything is same, then it is crossover.
Crossover. Okay. Okay.
Okay.
Yes.
So about the rollover, it is completely opposite to that straight through. Everything is opposite.
Okay.
One will go to 8 and two will be going to 7. See here. One is going to 8, two is going to 7, 3 is going to
Okay.
6. Okay,
6.
basically this is what a control cable is with a
Ah,
serial
okay.
interface with an RJ45 jack.
Ah, okay. 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 Okay.
Okay.
So this one you can use for your
This
laptop, isn't it? That
yeah.
bit
So
you put in a
this
laptop, and then this one you put into the this thing.
yeah. So the serial cable will be connected to your laptop. This
Yeah.
RJ45 jack will be connected to the router or the switch.
Router or switch or yes. Okay.
Yes. So this is what actually the cable types that we should be
Can you?
understanding.
Yes. Can you type in quickly the repeaters? Let me see how this one look like. Repeater.
Repeaters are it is not even a device something like you need to consider about like a switch or hub.
Oh, okay.
It just boosts the signal from one point to okay, something like this you can consider.
Ah, okay.
Basically, how we are boosting our Wi-Fi signal
Yeah, yeah. I have
from
one in my house. That's what I'm using now with you. Yeah,
okay,
yeah.
okay.
Here,
It
here
is
we
the
call it home plugs.
no, I don't refer to that Wi-Fi access point. Okay, the
Oh, okay.
repeaters what I was referring to is something these cable repeaters where you'll be
Oh, okay.
plugging in your copper cable or fiber cable. From there,
Yeah.
again, it will extend and it will go to some other point.
Oh, okay, okay. I've seen that one in supermarkets. Like when the cable, they go only up to like maybe 100 meters, then they put a repeater and then connect
Yeah,
another 100-meter like that. Yes?
yeah. Why? Because that signal is capacity is to run for only, let's say that 5 kilometers. After five
Yes.
kilometer, we need to boost that signal to
Boost
go for
it,
another five
otherwise it would
kilometer.
drop. Yes, otherwise
Yes,
the signal would drop. Okay, okay.
right. So that is for the
It's
purpose
similar
of the
to what
repeaters.
yes, okay.
So basically, hubs are referred to multi-port repeaters. We'll see the function of hub and switches by tomorrow.
Okay,
Hopefully,
okay.
yeah. So that's it for the day. Is there any
All
doubt
right.
or?
No, that's it. It's very good. A lot of
Yeah.
things I understand now.
I
Yes.
appreciate that you could sit for so long. It is
No,
more
don't
than
worry,
two
man.
and a half hours.
Don't worry. I want to understand this thing, so I am very eager, to understand and know exactly what I'm
Great.
doing, So,
For lastly, I don't have my personal laptop because I came to native due to this pandemic lockdown, and I couldn't have chance to go back to workplace where I have the laptop, so I don't have it set
okay.
up. But if I want, I can guide you through that. Uh, Basically, I use GNS3 with VMware,
Yes.
but I haven't worked on event.
Okay.
Wo-
You haven't worked on EVNG, yes?
It is there. I have used it. How does it work? But I never set up a lab in EventG.
Oh, oh, okay, okay.
I
Because
prefer
I have
GNS3.
I have EVNG here,
Mhm.
but
Okay.
I'm a little bit stuck here. I've got all the file. I don't know if
Mhm.
you can see,
Okay.
but how to put it on the OVA is where my problem is. But
Yeah.
If you have Genius 3, is no problem. We can install Genius 3. Is good for me as well.
Great. Do you have VMware with you or?
Yeah, I have VML already installed. VML
Great.
Pro
Okay.
15.5 already
Great.
installed on there. Yeah.
Great. Okay. Then it will be just like a piece of cake for you. GNS3
No.
is very user friendly. You can start
Okay.
using it. I'm
Okay.
struggling for that to get my laptop here. Even I need to learn a lot of things for network automation.
Oh, okay. You're doing automation now, yes?
Yeah, I'm learning. I'm just
You're
beginner
learning
for that.
automation. Okay. A lot of people doing automation and definite now because everybody
Exactly.
moving to cloud now, isn't it?
Right, right.
Yeah. But I want to understand this one first, and then later I go into
Great.
cloud.
Always foundation is a great thing to learn. Okay, John, then we'll
All
meet
right.
tomorrow.
Thank you.
Uh,
I'll let
okay.
Abdul know if
John,
tomorrow is okay.
can I talk now? John, tomorrow is a week off for you or work for you?
I'm gonna I'm gonna check with my boss today, and then I'll let you know.
Okay, okay,
I'm gonna text you, yeah,
okay.
because I don't
You
know
can
if
text
they're
me.
gonna call. Yeah, I will text you because I don't know if they're gonna call me tomorrow or I'm gonna be off Thursday or Friday. I'm gonna let you know. Okay.
Okay, you can tell me before one day.
All right.
It will be better.
Yes, no problem. No
Okay,
problem. Okay.
Okay, John,
Thank you
then
very
have a good
much.
rest. Bye.
Thank you very much. Yes, thank
thank you,
you.
Bye,
thank you,
Abdul.
thank you. Thank you.